Hi there. So this lesson is looking at the Higher Human Biology course and it's looking at the Unit 2 work covering Key Area 2.6 and in particular we're going to look at the cardiac cycle. So at the end of this lesson I'm hoping that you will be able to do two things. You'd be able to describe the cardiac cycle including using the terms atrial and ventricular, systole and diastole. And you should be able to describe the effect of changing blood pressure on the AV valves and the SL valves of the heart. So when we think of the cardiac cycle, what I want you to think of when you hear that word or the words cardiac cycle, I want you to think of one heartbeat because that's what a cardiac cycle is. And you're going to have to be familiar with these two words now as well, systole and diastole. Systole just means contract and diastole means relax. So when we think about the heart's made up of 4 chambers and these are hollow chambers and they basically just fill up with blood. And when blood is moved from one chamber into another, obviously the chamber would have to contract, the muscle would have to contract to squeeze that blood out. And when the chamber fills up with blood, it wouldn't contract, it would be relaxed. So when we think about your heart beating, it goes through this cardiac cycle and it involves chambers of the heart contracting and relaxing. So in the note it says the term cardiac cycle refers to the pattern of contraction or systole and relaxation or diastole shown by the heart during one complete heartbeat. So in the diagram below, there are 3 stages to the cardiac cycle. And in the first stage, it's called atrial systole. So if we'll just look at the words atrial and systole, that means that the 2 atria, the 2 chambers at the top of the heart, are contracting. So if they contract, the blood would then be getting squeezed out of the atria and into the 2 ventricles. The second stage of the cardiac cycle is known as the ventricular systole stage. And as the name suggests, the ventricles contract. So all the blood that was in the ventricles are now being squeezed out of the ventricles and they leave the heart, the blood leaves the heart through the aorta and the pulmonary artery. And in the third diagram, that's showing you what happens when all 4 chambers of the heart relax. So this stage is called atrial and ventricular diastole. So at that point, that's when the blood is going into the chambers of the heart and the heart is filling up. All the 4 chambers are filling up with blood. Sometimes in an exam, they might ask you to calculate the heart rate of an individual in beats per minute. And they might give you a diagram like this and expect you to be able to work out what someone's heart rate is. So this diagram is showing you one cardiac cycle. So you must just remember that one cardiac cycle equals 1 heartbeat. And in the diagram, there's a key there and there's a black box and a white box. The black box represents systole or contraction and the white box represents diastole or relaxation. And underneath the key we have our timeline and it goes from 0 seconds to 0.8 seconds. And on average, that's how long one cardiac cycle is, 0.8 seconds. So when we look at the times from 0 to 0.8 seconds, and then we can look at what's happening in the atria and in the ventricles at each stage of the cardiac cycle. So in the atria, we can see that for the first 0.1 seconds, the atria are contracting, and then for 0.7 seconds after that, the atria relax. In the ventricles, they're doing opposite. So for the first 0.1 seconds in the ventricles, the ventricles are relaxing, so filling up with blood. and then that's followed by a period of time when they contract. So when they contract, they're squeezing the blood out, and then from 0.4 seconds to 0.8 seconds, the ventricles are relaxed, so filling back up with blood again. So on average, the length of one cardiac cycle is 0.8 seconds. If this is the case, calculate the heart rate in beats per minute. So if you know that 1 beat equals 0.8 seconds, then how many beats will you get in 60 seconds? So to be able to work that out, you would basically divide 60 by 0.8 and get 75 beats per minute. Now, doctors can use a piece of an instrument called a stethoscope to be able to hear somebody's heartbeat, the sounds of the heartbeat. But what is it that's actually causing this sound, this heartbeat sound that we get? Well, the thing that's causing it is the valves. When the valves close, especially when they close, that's when we hear the sound of the heartbeat. So the AV valves are called atrioventricular valves, and they're found between the atria and the ventricles. And then you've got the SL valves, which are the semilunar valves, and they're found just before the entrance of the aorta and just before the entrance of the pulmonary artery. Now, this diagram is showing you the structure of the heart, and I'm hoping that if you did National 5 biology, then you are familiar already with the structure of the heart, with the 4 chambers and the 4 main blood vessels as well. Now, the valves aren't labelled on this diagram, so you should be familiar with the locations of the semilunar valve and the AV valves, the atrioventricular valves. But when we look at the cardiac cycle, we always need to use these 2 words, and it's at the bottom of the diagram, systole and diastole, to be able to describe what's happening in the cardiac cycle. So on the right-hand diagram first, it's showing you systole happening. So that's describing when the ventricles contract. So by contracting, they're pushing the blood out of the ventricles, and the blood then leaves the heart by the aorta or the pulmonary artery. On the left-hand diagram, we can see that that diagram represents diastole. So in diastole, that means relaxing, so the chambers are relaxing, and then that allows the blood to flow in and fill up the chambers with the blood. So for the cardiac cycle itself, you need to be familiar with the 3 stages of the cardiac cycle. The diagram shows you those 3 stages, and because it is a cycle, it just keeps repeating itself. So it doesn't matter what stage you start with, it just keeps on repeating and going round. So the 3 stages you need to know are the atrial and ventricular diastole stage. That might be number 1. The second stage would then be atrial systole and ventricular diastole. And the third stage is ventricular systole and atrial diastole. So you need to be familiar with these terms, systole and diastole, and you need to know where the atria and the ventricles are. So if we take each one of these and explain what's happening for everyone. So the first stage is called atrial and ventricular diastole, and if you think about that name, it tells us that all the chambers of the heart are relaxed. So because they're relaxed, they are filling up with blood. So nothing is being contracting here, none of the chambers are contracting, the heart is just simply filling up with blood. So blood will return to the heart into the atria from the vena cava and the pulmonary vein. For the blood to then go into the ventricles from the atria, the AV valves need to be open, and that allows that blood to flow into the ventricles. Now, On the diagram for the first stage here, atrial and ventricular diastole, it shows that it takes about 0.4 seconds on average for this stage to happen. This is the longest stage of the cardiac cycle. The second stage is called atrial systole and ventricular diastole. So as the name suggests, the atria are contracting and the ventricles are relaxing. So when the atria contract, that means that the blood that was in the atria is now being squeezed down into the ventricles. So the AV valves need to be open again to allow that blood to move from the atria down into the ventricles. And to prevent the backflow of blood into the veins, the pulmonary veins and the vena cava, then the ring of muscle around the entrance to each atria needs to be closed as well. Now this stage is the quickest stage in the cycle and it only takes 0.1 seconds. The third stage is called atrial diastole and ventricular systole. So after atrial systole and ventricular diastole, this is the stage that follows on. The AV valves now need to close because if the ventricles are now carrying out systole, so they're contracting, then that blood in the ventricles is moving out from the aorta and the pulmonary artery, and you don't want that blood to then move back into the atria. So the AV valves need to be closed to prevent the backflow from the ventricles to the atria. The ventricles, when they contract, they pump the blood out and the blood then moves through the semilunar valves, so they must be open, and the blood then leaves the heart by the aorta and the pulmonary artery. Now, as the blood leaves the heart, then the semilunar valves will close. Now, they only close when the blood pressure in the arteries is greater than the blood pressure in the ventricles. So as soon as that blood pressure gets too high, the valves will close. And we're back to the beginning of the cardiac cycle again. It just keeps repeating itself. So this slide here is looking at the pressure changes and the heart sound. So if we look at the graph first of all, you can see that the graph on the x-axis is looking at time from 0 to 0.8 seconds because that's the average time for the cardiac cycle to occur. And in the y-axis it's looking at the blood pressure, which is measured in millimetres of mercury. So when we look at the graph, from 0 to 0.1 seconds, that's when the atria would be contracting. And once the atria contract and move the blood, squeeze that blood from the atria into the ventricles, then the AV valves need to close to prevent that blood flowing back from the ventricles into the atria. So on the graph, just after 0.1 seconds, you can see that the AV valves close. From 0.1 seconds to around about 0.4 seconds, that's when the ventricles are then squeezing and contracting. So ventricular systole is occurring, and that allows the blood that was in the ventricles to squeeze out by the aorta and the pulmonary artery. Now, when that blood is being pushed out, you can see on the graph just after 0.4 seconds that the semilunar valves close, the SL valves close. And why are they closing? Because the pressure in the aorta is greater than the pressure in the left ventricle. So that's the reason why they close. And from 0.4 seconds to 0.8 seconds, that is when all of the heart chambers are relaxed. So atrial and ventricular diastole is occurring. The bottom diagram is showing you the heart sounds on a phonocardiogram, sorry, and it's showing you the two sounds that are made when your heart beats. So the classic two sounds is referred to as lubbed up. That's the name of the heartbeat. Lubbed up, that's the two sounds. And the reason why they occur is due to the valves closing. So if you refer where you can see lub, the sound of lub on that bottom diagram, and you correspond that to the graph, so take your finger from lub and go all the way up to 0.1 seconds on the graph, you'll see that's when the AV valves close. So the reason why we get that first sound of the heartbeat is due to the AV valves closing. The second sound of the heartbeat, the dup, that occurs when, if you follow the dup up to the graph, up to about 0.4 seconds, that occurs when the SL valve closes. So when the SL valves close, that creates that second sound of the heartbeat. Okay, and that's you done for today. Thank you.